Okay, and finally, we're going to go through the last two problems that we are going to see how to be able to graph. So we want to understand how to be able to put all those together and draw them just like we did in the last um, video. So first off, we know that we go up 2, we go to the right 1, and we go up 6 times faster. Okay, so this one we're going to have to kind of give a general idea. I'm going to show you what it does based on whether it's 6 or a 1, because we're going to graph it with a 1 and then graph it with a 6, and you'll kind of get an idea of what happens when this number is bigger or when it's smaller. So kind of understanding that, we know that it goes up 2. We know it goes to the right 1. So we know that right at the center point is where everything is. It does not shift over the horizontal or over the vertical in this particular case. So we have the function is going to look something like that. Now, what does the 6 do to it? Well, that's where we're going to look at what's happening here. And we don't know exactly where it's crossing that axis either. So we kind of have to get a general idea. Now, we can figure it out because notice here, x is equal to 0. So if I make x equal to 0 here, we can have a general idea of what's happening with this particular function. So when x is equal to 0, we get f of 0 is 6 over negative 1 plus 2, which is negative 6 plus 1, which is negative 5. We're not even close, right? So it's telling me that 4 and then 5, so it actually should be crossing the axes there. So that means that my function should probably be going down something like that. Probably that curve isn't very good there, but you notice that it should cross here at this particular point, which is 0, negative 5, right? X is 0, y is negative 5. So we can do that, 6 over x minus 1 plus 2. So we're going to do that now. So we're going to have 6 over x. We're going to change that to a 6. 6 over x minus 1. And then minus 5. Can't I remember? So we go back and look. Oh, plus 2. Wasn't even close. And then plus 2. So notice with this function what it's doing. Notice here, it should be at negative 4 because I don't know how to add. And that makes more sense, right? Because should be plus 2 here, plus 2, which is equal to negative 4. But what's nice when we're doing predicting is that, again, I've made a couple of mistakes here, right? Instead of putting plus 2, I put plus 1. So that's where we get the negative 4 from, because that should be a 2 instead. So it should be crossing right at this point. And notice here that it does that. It crosses right at that point right there. So we can see that. But it never quite hits 1. Now notice if I have a 6 here, I'm going to make this now a really large number. So let's go backspace and we're going to go 20. Notice how with 20, where it moved out to. So you can kind of get a general idea, right? 2, 20. Okay. 0.2. Okay, notice how the smaller we get, the more of a corner it becomes. It's still kind of a curve, but notice how when the number up here, a, is between 0 and 1, notice what's happening there is that it's not going up as fast, right? It's kind of hard to see that because going up, you think of it going up in this direction. So notice if I put a number in front of there, 5, notice what happens with that versus not. And then we can kind of see what happens with 10, right? So it kind of spreads out a little bit as it goes through the values. So you kind of get a general idea of what's happening with that particular number. And you can kind of predict what the function is going to look like. But notice I can also calculate some values because I could figure it out at 0, because 0 is this particular point. I can figure out what it should have crossed, and I made a mistake, right? So you always have to be careful with that. Okay, on the next one now, this is also kind of a similar type of function. It's not really a reciprocal function, but it's something that you're going to get into the next lesson. So if I factor, anytime I see an x squared term and see something like that, I know I'm going to have to factor. Now remember, if this is a 1, I just have to figure out what the factors are. So this is negative. That tells me one is positive, one is negative. This one tells me the larger number is positive. So I'm going to write it as negative plus. And the reason why I do this right away, and the larger number always goes on this side. So larger here, smaller here. What are all the factors of 12? I'm not worrying about negative 12, but 1 and 12, 2 and 6, 3 and 4. The two numbers have to add up to positive 4. The only ones that do that are these two. So I have x minus 2 and x plus 6. So now I have two vertical asymptotes. So if I were to draw this, I'm going to have one at positive 2, 2, 3, 4, 5, 6, and I'm going to have one at negative 6. So I have one at x equals 2, and I have one at x equals negative 6, right? Because I'm solving for x in both of those cases. So x cannot equal either of these values. So notice I have two asymptotes. Now, what does that mean? Well, we haven't even talked about a parent function of this type of equation yet, but I'm going to show you the parent function, or what it kind of looks like. It's going to look something like this if I don't have a negative up there. Whoops. See, I keep doing that. And you know, that's the one thing I want to be careful about. So I caught myself this time, but you have to be careful because this should be going over to the asymptote. And then on this side, I've got this. So notice here, the kind of parabolic shape that goes over here, which is really more of an exponential shape, and this one being a exponential shape as well. And then we can see this one here is more parabolic, kind of parabolic. And so we can kind of get a general idea of what that looks like. Now, notice that the axis doesn't go up or down. Otherwise, there would be a number out there. The 6 tells me that it's tighter. It's a tighter curve. So I probably should have drawn it a little bit more tightly on both sides because that's what's happening. And that means that it would actually be tighter here as well. So it's still curved. It's just that it's a little tighter curve. And so let's predict that. Let's see if that's what it looks like. 6 over x squared plus 4x minus 12. So 6 over x squared plus 4x minus 12. And notice here at negative 6, there's an asymptote. At positive 2, there's an asymptote, just like we showed. And notice this tightness here. Now notice if I change this to a 2, does it change it all that much? Not really, but if I change it to 20, notice it does make a difference. Okay, 2 and 6, not much of a difference, but 2 and 20, you can definitely see the difference and see what's happening there. Okay, that's it for reciprocal functions, and now we have a better idea of what these functions look like and how they shift around.